Hello, curious minds. What if I told you that advanced alien civilizations might be out there, capturing the energy of their stars with colossal megastructures? Today we're diving into the fascinating concept of Dyson spheres and what they could mean for the future of humanity. Get ready to explore the insane idea of harnessing the power of an entire star. Alright, let's start with the basics. Imagine a sphere so massive, so amazingly huge that it completely envelops a star, capturing all of its energy. That, my friends, is a Dyson sphere in a nutshell. It's like wrapping an entire sun in a giant solar panel, but on a scale that would make even the most ambitious construction projects on Earth look like child's play. Now, you might be wondering, why go through all that trouble? Well, the answer is simple: energy. A Dyson sphere would allow a civilization to tap into that power source directly, essentially making them a Type 2 civilization on the Kardashev scale. We'll talk about this scale later. The concept of a Dyson sphere might seem like something straight out of science fiction, but its origins can be traced back to a real scientist, Freeman Dyson. Dyson, a brilliant physicist and mathematician, wasn't actually trying to design a megastructure. He was more interested in finding a way to detect advanced alien civilizations. He reasoned that if a civilization were to reach a certain level of technological advancement, they would inevitably need to tap into the vast energy reserves of their star. Dyson proposed that the telltale sign of such a structure would be the emission of infrared radiation. See, even a Dyson sphere would have to radiate some heat back into space, and that heat signature would be detectable by telescopes here on Earth. While Dyson himself acknowledged that building a solid sphere around a star would be practically impossible, he envisioned a more feasible alternative: a swarm of smaller structures, perhaps satellites equipped with solar collectors, orbiting the star in a dense formation. This concept became known as a Dyson swarm, and it's considered a more realistic scenario for a civilization to achieve. So, we've talked about the what and the why of Dyson spheres, but what about the how? If an advanced civilization were to build one, what might it look like? There's no single blueprint for a Dyson sphere. Scientists and writers have proposed various designs, each with its own complexities. The classic image is a solid shell enclosing a star, known as a Dyson shell. It's visually striking but presents serious engineering challenges. Other designs include the Dyson ring, a ring-shaped structure. Then there's the Dyson swarm, involving smaller structures orbiting the star. A Dyson swarm is modular and can be built incrementally. Let's talk about energy. Really talk about energy on a scale that dwarfs anything we've ever imagined. We're talking about harnessing the full power of a star. A cosmic furnace that churns out more energy in a single second than humanity has consumed in its entire history. To put this into perspective, our sun, a fairly average star, releases about 384.6 septillion watts of energy every second. Even if a civilization could capture just a tiny fraction of that energy with a Dyson sphere, it would be enough to power their most ambitious endeavors for millennia. But what could you actually do with all that energy? Well, the possibilities are as limitless as the universe itself. Imagine a civilization capable of interstellar travel, zipping across the cosmos at speeds that make our current spacecraft look like snails. With a Dyson sphere, they'd have the energy reserves to power those journeys, opening up the galaxy to exploration and colonization. Then there's the realm of computation. We're already pushing the limits of Moore's law, but a civilization with access to a Dyson sphere's energy could create supercomputers of unimaginable power. The energy potential of a Dyson sphere is so immense that it fundamentally changes the game for any civilization that manages to build one. Okay, let's get real for a second. As awe-inspiring and potentially game-changing as Dyson spheres are, we have to acknowledge the elephant in the room, or should I say the megastructure in space. Building one would be insanely difficult. We're talking about engineering challenges that make landing on Mars look like a walk in the park. First off, let's talk materials. To construct a Dyson sphere, even a Dyson swarm, you'd need a staggering amount of raw materials. We're talking about dismantling planets or asteroids to harvest their resources. And it's not just about quantity, it's about quality too. You'd need materials that are incredibly strong and durable to withstand the immense gravitational forces and intense radiation environment around a star. Then there's the issue of transportation. How do you move all that material from where you've mined it to the construction site? We're talking about transporting planetary masses across interstellar distances. And let's not forget about assembly. Putting together a structure that's larger than our solar system, would be like assembling a cosmic jigsaw puzzle on steroids. On top of all that, you have to consider the challenges of maintaining a Dyson sphere once it's built. Let's indulge our inner futurists and talk about the mind-blowing technologies we'd need to make Dyson spheres a reality. First, we'd need to master nanotechnology, manipulating matter at the atomic level, building materials with unprecedented precision. Imagine self-replicating nanobots mining asteroids and repairing damage at a molecular level. We'd also need to crack the code of fusion power, harnessing the power of stars, essentially giant fusion reactors. Designing and controlling a Dyson sphere would require computing power that dwarfs anything we have today. These technologies might seem like science fiction today, but remember, so did smartphones, the internet, and space travel just a few decades ago. If advanced civilizations out there have indeed constructed Dyson spheres, could we, even with our current technology, detect them? Well, that's a question that has fascinated astronomers and SETI enthusiasts for decades. While we haven't found any definitive proof of these megastructures yet, there are a few intriguing avenues we're exploring. Remember how Freeman Dyson originally proposed that a Dyson sphere would emit a distinct infrared signature? Well, that's still one of our best bets for finding them. Space telescopes like the Infrared Astronomical Satellite, or IRAS, and the Spitzer Space Telescope have scanned the heavens for unusual infrared sources, looking for objects that are brighter in infrared than they are in visible light. While these surveys have found plenty of interesting objects like dust clouds and distant galaxies, no confirmed Dyson spheres have turned up yet. But that doesn't mean we should give up hope. New telescopes like the James Webb Space Telescope, with its enhanced infrared capabilities, could provide us with even more detailed views of the cosmos, potentially revealing the subtle signs of a Dyson sphere's waste heat. The search for Dyson spheres is a testament to our insatiable curiosity and our desire to know whether we're alone in the universe. Imagine for a moment, astronomers detect an unmistakable sign of a Dyson sphere. What would that mean for humanity? It would be one of the most profound discoveries in human history, fundamentally altering our understanding of our place in the universe, and forcing us to confront the reality that we're not alone, and we're not even close to being the most advanced civilization out there. First and foremost, finding a Dyson sphere would confirm the existence of extraterrestrial intelligence, and not just any intelligence, but a civilization so advanced that it makes our current technological achievements look like child's play. This discovery would have profound philosophical and religious implications. It would challenge our anthropocentric view of the universe, forcing us to reconsider our place in the grand scheme of things. On a more practical level, the discovery of a Dyson sphere could provide us with a wealth of knowledge. By studying its structure, its energy emissions, and its movements, we could learn a great deal about advanced engineering, physics, and perhaps even unlock the secrets of faster-than-light travel or other technologies that seem impossible to us today. Now, if we're talking about civilizations capable of building Dyson spheres, we're talking about civilizations far more advanced than our own. And that's where the Kardashev Scale comes in. This scale, proposed by Soviet astronomer Nikolai Kardashev in 1964, provides a way to categorize civilizations based on their energy consumption. At the bottom rung, we have Type 1, or planetary civilizations. These societies harness the energy resources of their home planet. Next are Type 2, or stellar civilizations. They harness the energy of their star, and that's where Dyson spheres come in. And then there are Type 3 civilizations, the galactic civilizations. They have access to the energy output of their entire galaxy. So where do we stand on this cosmic ladder? We're not even a Type 1 civilization yet. We're still a Type 0 civilization relying on fossil fuels. The Kardashev Scale is more than just a way to measure our progress. It's a roadmap for our future. It shows us the incredible potential that awaits us if we can overcome our current challenges and push the boundaries of science and technology. Scientific exploration requires considering alternative perspectives and healthy skepticism. While Dyson spheres are fascinating, there are valid critiques and counterarguments to their feasibility. The main criticism is the immense engineering challenges and resources required. Another critique is the difficulty in stabilizing such a large structure under its own gravity and the star's radiation. There's also the question of how a civilization would harness and transmit the captured energy efficiently. Critics argue that advanced civilizations might have more efficient energy methods like tapping into black holes or zero-point energy. Not every unusual astronomical observation is evidence of alien megastructures. We must balance enthusiasm with scientific rigor. So where do we go from here? While we might not be building Dyson spheres anytime soon, the technologies and concepts involved continue to inspire new avenues of research and development. The challenges of building a Dyson sphere might seem insurmountable today, but history has taught us to never underestimate the power of human ingenuity. The universe is full of mysteries, and the quest to unravel them is what drives us forward. Whether we find Dyson spheres or not, the journey itself is what matters, for it's in the pursuit of knowledge and understanding that we truly discover our place in the cosmos. That's all for today's deep dive into the fascinating world of Dyson spheres. Now, I want to hear from you. Do you think humanity will ever achieve the technological prowess to build a Dyson sphere, or will we find alternative solutions to our energy needs? Let me know your thoughts in the comments below. Don't forget to like, share, and subscribe for more videos on future technologies and the mysteries of the cosmos. Thanks for watching. Until next time, keep looking up.